Wow, once again, we're almost at 5,000 subscribers. Thank you so much. This is the start of a new animatronic design. And I wanted to show you a little bit about SketchUp. The reason why I really enjoy it so much. It's quick and easy. Make a cube, make a square, easy. And I love it when I can find center, like you see here. And measurements. I like measurements, like where I can just click on my measurement device, click on a line, and it will give me the proper measurement. And I've printed a lot with SketchUp, and it's accurate. Okay, this is part one of a 3D printed new animatronic design. I'm going to have multiple servos in this head, and it's going to be small enough to where we can print it and also make a resin print and be able to make a mold of the resin print to make the skin. And this is going to have a lot of realistic movements. So this is the beginning. Well, to start, this is the servo. This is the wing servo. This should save me some space. This is the C410. This is from King Max servo. It's a wing servo. I have these servos coming, so I can start designing and get started on this and share it with y'all, the whole process of designing a 3D printed animatronic. We're gonna shoot for 8 servos. I think I'll have enough space to make this happen, especially with the size of these servos being so thin, and I'll be able to, and screw points matter too, and that these are, vertical screw points instead of horizontal. But this is a bead. This is what they call a gumball bead, and they have a 2mm hole going straight through. And I'm contacting all of the suppliers that all the parts I need for this animatronic to make sure I have them in stock. So make sure my Patreons will be able to have them available. But as far as the servo rotation is 70 degrees. But here I'm just making these circles and or center points onto the servo arm. That way I can draw onto the servo arm itself, and mainly just to get a center point of the axis, and that way I can get a measurement from one point to another. But I'll just make sure that this is at the correct height. And then as you see here, my eyelids, the rotation won't go back this far. It'll open wide, especially when you have skin on it. You'll see it'll be open pretty wide-eyed. But in the lower and the upper eyelids will be connected to one servo. And then when I start designing the linkage, I'll just take the measurement as you see here. I think it was 2742, and I'll just make a line 2742 and make circles, and then I'll put the screw points, and then I'll just line them up like so, and then I'll extrude it to make my linkage. But it's a design thing, and sometimes it can get tedious, but it's things like screws will be like 2mm screws and nuts, and it has to be able to make sure that those are clear from any obstacles. Make sure that it's probably going to be some nylon 2mm nuts also. That way it'll be like a locking. And then every once in a while I will use them small tiny washers, and you can get a whole pack of these multi-link 2mm screws. But I'll just duplicate the top one, and I'll stretch the other one according to the measurements to the lower linkage length. And you'll see these lines coming out of these holes. Those are my axis holes where I can just, combine them together or, match up to another hole that has that line coming out just to match up the axis. I recorded today about three and a half hours of footage, and I'm just going to be and I've edited it down to like 30 minutes because I've had to speed up some of these because some of the times you see me in there and you can tell when I'm thinking, but it's just part of it because I got to just make sure that everything's clear, or can I put this here or put that there, because you have other things like wires, and you got other I want to put other things that move, and I just got to make sure that I have clearance for the next thing. But this is basically part of the designing. Now, these things would probably be best to be printed in some type of, carbon fiber, or, the whole thing would be great in carbon fiber. That way it'd be strong and wouldn't be breaking, or, PLA is pretty strong, and, all the stuff that I've done already has been PLA. But as you see here, what I'm designing is an arch. Now I really need to flip this over where the bow is upside down. Just didn't get it around to it, but that way it would be stronger the other way. But and the same for the lower. They should be both flipped, but I'll flip them later. But it's just a lot of planning and to make sure I have clearance. And once again, this is going to be like modular, so I'm doing one eye here and then I'll mirror it. You'll see this in a few minutes. Now I'm making the center axis supports for the eyelids. This is what's holding the eyelids and the ball in place. There will be a through rod through this whole axis point to where it holds the bead and the eyelids. Now a lot of this is like in a rough design. I mean, it's accurate, but as far as to where I can come back and there is what I call a cleanup time, to where I start cleaning up all the things before I print. And like when I have all the sockets in place for the servos and stuff like that, I try to avoid a lot of supports, and then I'll slice whole panels just so I can print flat to avoid supports, and because I don't want anything to break being in a PLA test. Now here's the lid support, and it has a center axis, but it's having eyes looking straight, but technically most creatures don't have straightforward, center axis eyes. I like to make mine tilt a little bit. I will either have a 2mm rod going through this support, or a 256, RC rod they call them. But it will have lock nuts on the end for each set of eyelids. I mean, this one right here is pretty clean coming out, and everything's flat. I even rotated earlier today. I kind of rotated that servo, at a 90-degree angle, and I thought about that, and it's possible that I might change that also. But it's just, you got to work things out, because the way it looks like, I might have a table on top of this servo, and this servo table will hold like the other mechanisms that are going to be working, like for the eyebrows, and there's another, like a cheekbone. The cheekbone doesn't move, but the muscle does, and that would make it, squint. And that's another thing I'm trying to calculate. But you see here, I'm doing a rotation of the eyes to give them to where they're not just straight on. And then I'll do another tilt. And the first one was a 8 degree, and this is a 10 degree. Just give them kind of a cat looking look, I guess you call it. But it kind of gives the creature a little bit more personality, I feel. Now what I'll do is I'll open the component up to each one of these eyes and connect the eyelid supports together to make one component. Here I'll just draw lines to each corner and just connect it, make it into a plate. I appreciate all the questions, and I'm trying to answer all of them. There's a lot of them, and I appreciate that. But as far as like a servo controller, I can control these two servos with a controller. Just plug up the servos to the controller, add power and a USB, and I can program it. But like right here, what I'm doing is that, once again, I have a library of parts. And this is the alien that I did, that y'all been seeing the move. Its jaw and where the teeth goes to. And I'm going to put a servo onto this jaw, so I'll have another servo open and close the jaw with the servo there, and the servo that's on the jaw will be pulling the lower lip up and down. And it has to be done that way. I'm just trying to bypass cable or either guitar string. That way I can have a direct line to it. I can't put it anywhere else because the jaw servo will lock up the other servo. So this servo has to be in the jaw to get this to work. As time goes on, there's some, RC supplies get discontinued. And plus I'm trying to avoid putting cable housing, which one of my good small cable housing has been discontinued. So I'm going to just go directly with this servo here and to move this lower lip. Here, making a screw point socket for this servo. Just I'll just copy the tab and then just extrude it, the screw points, and then connect the two tabs together to make a socket for these wing servos. I'm right clicking to get rid of the component of the servo, but you're not seeing the other window that's popping up. I'll make sure I'll make that correction on the next video. When you design an animatronic, you put a lot of time in it, and you can get to where you spend hours, and days, and weeks, and months. But I've done so many, I can do it pretty quick, but it's still, you have to keep double checking. But it's a great feeling when you make something and you see it move. Now this servo is small and it's flat, and I'm trying to get it into this jaw, but I'm going to make sure that it fits well, so I'm going to widen this jaw. Then you'll see I'm trying to line up this servo arm to center, but it can be a little to the side, but I'm going to go ahead and remove half of this jaw, and then I'm going to enlarge it or just, stretch it out a little bit and make it a little wider, so that way I won't have any issues in a way to hide this servo, even though it's going to be behind the jaw and the skin's going to be covering it. That way it just be out of the way and won't be bumping into anything that's behind it. And later on, next video probably, I'll make a low poly set of teeth, and I'll make a high quality, highly detailed set of teeth. I'll copy the plate of the lower jaw and the plate of the upper arch, and then I'll put them into a blender and I'll design it. I have a library of teeth I've made, and that way I can cut it to make an accurate bite to where they fit these plates and they just fall in place and get just a perfect bite. We're working on the upper arch and the height. The whole mouth can be higher or lower, but I try to keep it more compact. And before I make the adjustments for the upper lip movement, I'll make a kind of a rough set of where the teeth are going to be. Just a form and a shape of teeth, or where the teeth are going to go. And since we got a servo in the jaw, it's going to make the mouth somewhat bigger, so we have to cover this servo. But just a fake little form for me to rotate around with the lip mechanism. Now this is going to be where I'm going to put the location to the lip movement axis, and there's going to be two paddles or two lip movements here on the upper teeth and one on the bottom. So each of these movements, that would be equal to be 3 servos that's going to be working this. But the axis to this lip movement needs to be in a certain location for the rotation and moving of the lip in a correct position. Now this whole thing will be remodeled, and the hinge point at the back, if you see here, if I rotate it too far high, it will pull away from the teeth, and that'll make it look strange. But if you go lower, it hugs the teeth closer, so it's more natural how the lip, moves around the teeth. There's not too many wing servos that are this small, and King Max is the only place that I really found them, and I'm sure that they exist, but this is the smallest one I could find that was that small. Just, the smaller the animatronic, the smaller the printer will need to make this, this bust to be molded to make the skin. Now, as far as me remodeling here, the lower lip movement, I'm just getting something a little bit closer to hugging the teeth, and then I'll find its axis, and see it's pulling too far from the gum or teeth area. So I'll just locate this axis and go from there. Here I'm going to chop up this jaw to where I can mirror it, make it wider, so I can lay this servo in there closer to the jawbone itself. I will add a chin to it later, and then that way that lower lip mechanism can kind of tuck underneath the teeth and kind of hide that mechanism. When it opens up, it won't have a bulge, but yet the bulge could be another movement underneath the chin area. And during, like cleanup, when I start really getting down on each mechanism, like with the paddles, I can put like little sockets into the paddles because I want the paddles to grip the silicone also. And then when I make the core, that way it will be transferred to the core, and then when the skin is casted, the sockets will appear for the lip paddles and the brow paddles and so on and so forth. Well, when I start doing the skin work, I'm going to be using from Smooth On the EcoFlex 10. This silicone has a 4-hour cure time, but a lot of this remodeling the whole jaw and things like that, and also when I start making the skull, I can put a covering over this hinge point too to kind of give it more of a jawbone appearance. And then you can also, we'll be able to see that through the, when I do the sculpt, we'll see it move through the skin. And that's my goal. The whole thing is I want this to have some realistic movements, and it should, especially with this Smooth On EcoFlex 10. And when you apply it, and I use this Silpoxy adhesive, and when you apply it, you put it in certain spots on the skull that you're sticking. You know you're going to stick the eyelids, and you're going to apply it to the paddles that we're moving. But you also apply it to certain parts of the skull. You just don't paint the entire front of the face and stick it, because you're not going to get that really that flesh look, that muscle movement look if you just glue it all. It's just not going to work that way. Now I just worked on one side and mirrored it. Now I have a wider jaw. Now I'm going to rotate this servo to where I can get it matched up with the bone, the jawbone itself. But I need to flip this servo. That way the servo arm is on the bottom instead of the top. But it's just this kind of tinkering design. To I'm building a watch. Okay, I pulled back on the jaw, the teeth, and the lip mechanism, and I'm going to add the teeth to from the other alien I did. I'm just going to resize it to this arch here, and that way I can get a basic shape for the lip mechanism and just the whole creature itself. But I will redesign these teeth that actually fit these arches here. Yeah, the teeth make the creature, and the eyes too. But I'll remodel these teeth and to match them up to these arches and give it its own kind of expression. But I'm gonna, here where I made the eye plates, I'm gonna adjust those too. But to where I'm gonna bring the eyes in a little closer together. I moved them in 3 millimeters. I don't think you've seen it yet, but it's coming up. But compared to the other animatronic, that's a working mech, but that's the other servos, the standard servos. But these wing servos here should give me a lot more space, and plus be able to reduce the size. Made the eyes a little closer, 6 millimeters closer. And that's looking good. Have a lot more work to do, and have, I believe, 5 more servos to add, equal 8. But we're going to play around with this. But this has been part 1 of a 3D printed animatronic creature. And part 2 coming soon. I appreciate all the support, all the new subscribers, and I'm glad y'all like it and have the interest that I have. Thanks again.